All right, welcome back to another one of my home lab videos, where today we're going to be building on our local LAN, local area network. So what you see in front of me right now is a Raspberry Pi, and during this project I learned a lot. There was a lot of mistakes made, there's a lot of research, there was a lot of Googling done to figure out what was going on. And to make a long story short, I realized in something that was touched upon in the A+ exam is that when you plug a client machine to another client machine, which in this case the Pi and my MacBook, you have to use a crossover cable. Now, you might run into cases where the Ethernet adapter that I'm using for my MacBook has that MX crossover capability, but in this case it didn't. So it caused me a lot of grief and a lot of problems. And so I'll touch upon that later on in the video. But for now, first step is that we have to load up the operating system in the Raspberry Pi. So the first thing I'm going to do now is I'm going to flash, as they say. I'm going to download the Raspberry Pi operating system that's called Raspian, which is a distribution of the Linux Debian operating system. So I'm going to flash it, meaning I'm going to save it onto the micro SD card, and then we're going to plug that, we're going to insert that micro SD card into the Raspberry Pi, and we're going to use that to boot up the Raspian operating system to the Raspberry Pi. But without any further ado, let us fast forward and start the troubleshooting process. Okay, so this is the point where things got tricky. So like I mentioned before, when you connect two client machines together, you need some crossover technology. You can't connect a computer to a computer directly, or a switch to a switch, or a router to a router. And that's something that was covered in the A+, or it might have been in the Network Plus. It's hard to remember where that was covered. It might have been the Network Plus, but I didn't remember. So what I'm trying to do here is I'm trying to eventually SSH into my Raspberry Pi. But first I wanted to test if I could reach it, so I needed to ping it. I wanted to ping it. And in the instruction manual for the Raspberry Pi, it says that typically the host name is raspberrypi.local. And so that wasn't working. And so I was like, okay, well, what do I need to do? I need to discover what the IP address is. So let me do a search for the ARP table. So ARP-all to pull up the ARP table, which is basically a local, table, memory, database of IP addresses that have communicated on the network, that have communicated with the device and mapped to a MAC address. And so my ARP table is coming up blank, and there was no communication. And one of the things I was counting on was one of the things where I first started kind of going to is whether I doubted whether the Raspberry Pi was able to assign itself its own IP address, the IPIPA address, which is basically when a self-assigned IP address, when there is no DHCP server around, then devices typically just pick a APIPA APIPA address out of the 169.254 subnet and it assigns themselves one of that. So I was looking to see, maybe Raspberry Pi wasn't capable of doing that. So I was looking into all of that, and unfortunately it didn't lead me anywhere. So eventually there was a gentleman that was sitting behind me, and we struck up a conversation, and come to find out that he used to work at Sun Microsystems in device networking. So he brought up the possibility, he brought up the fact that without any crossover technology, you can't connect. He reminded me that you can't connect client machines to client machines. And he asked if I had a switch, and I told him that I had an unmanaged switch. He said, give that a shot. And so I decided that was the best move. One of the other theories that I came up with was maybe the operating system wasn't booting properly. So what I decided to do, I decided to pack up my stuff, take the Raspberry Pi home. It has an HDMI interface. It also has USB interfaces for a mouse and for a keyboard. So I decided to make sure that everything was okay with the Raspberry Pi and that it would boot okay. So I took it home. I decided to take it home and at least get the operating system booted up. Okay, so now I'm home, and the game plan is to, at minimum, connect the Raspberry Pi to my monitor and flash the micro SD card with the operating system. I at least wanted to take off the table the possibility that there was something wrong with the Raspberry Pi, that there was something other than network issues that prevented me from booting, that the boot process wasn't standing in the way between me and SSHing into the Raspberry Pi. So the goal here was to at least make sure that I was able to install the Raspian operating system into the Raspberry Pi. And here's when I had a couple of aha moments. So this is when I began the process of pinging the machines. So what you'll see now is that I have the Ethernet wire from the Raspberry Pi connected to my wireless router, and the laptop is connected to the router via Wi-Fi. And when I did an ARP-A, when I checked out the ARP table, it picked up the device. So it immediately became apparent to me, or clear to me, that the router was serving as also a switch. These modern day routers have built-in switches inside of them. But more importantly is that there is a DHCP server embedded within the router itself. So now I was able to go back and forth pinging the Raspberry Pi from my MacBook and also pinging the MacBook from my Raspberry Pi. So that became an aha moment. So then that begged another question of mine, which I wasn't sure, which I wanted to test out as well, is that, okay, the DHCP server is embedded inside the router. Would just connecting to the switch, would that kind of force the APIPA addressing? Or is the DHCP server necessary? Or because I have an unmanaged switch, that the DHCP server in the wireless router is, what would you say, best practices? So if whenever possible, a DHCP server is the best route to go, best thing to do, because the APIPA automatic addressing, when I come to think about it, is pretty unpredictable, right? Because there is no centralized organizing logic. There's nothing stopping from one device selecting the same address because there's no communication among them. So, but the more important part was that I was able to confirm that the operating system is functioning on the Raspberry Pi. The Raspberry Pi is booting with the desktop GUI, and there is nothing really stopping communication from the Raspberry Pi being on the network. There's nothing stopping network communications other than the fact that it's missing a DHCP server. So the next thing I decided to do was connect the switch and verify, or observe rather, what happens to the APIPA addressing protocol if the devices are just on the switch by itself without the router, which has the DHCP server, and see what would happen there. But I realized that I was missing a cable, so I needed to prepare the cable, and I was running out of time because I had to go run to work. So I started building out the cable, but this will have to be to be continued for the next day, which I discovered a number of very useful things that I don't think I will ever forget, which is why these home labs are amazing. Because one thing is the theory and the other thing is to troubleshoot situations, and these are the kind of things that never leave you. I don't think I'll ever run into a situation again where I'm going to forget that the client machine should not be connected together, and best practices or best optimal situation, or the best what would you say, the more logical topology is to have a DHCP server involved in assigning the IP addresses, because like I said before, the APIPA self-addressing protocol is unpredictable. So off to work I go. Alright, and so the mission continues, and I bring along my switch and the 2 Ethernet cables that I made, and I proceeded to connect the Raspberry Pi. Now that I know that everything's booting up properly, I have full faith and confidence in my Raspberry Pi. I connect it to the switch, and I connect the MacBook directly to the switch as well, with the hopes that it would force some APIPA self-address assignment. And long story short, I'll save you the surprise, it did not work. So I tried to ping the Raspberry Pi, knowing that it should ping from Raspberry Pi.local. I tried to run the ARP-A table to see if I can pinpoint what the APIPA address was, but no luck. So right then and there, I knew that I was going to need a DHCP server, and that was that. Alright, enter Mr. DHCP server himself, and at this point I had full faith and confidence that my Raspberry Pi was working, and I started connecting everything as I had been for the last 3 or 4 days, with a little bit of a 1% doubt but 99% certainty that with the DHCP server connected to the switch, acting as the centralized assigner of IP addresses, that everything was going to be okay. And here I am looking to see if the light is the network traffic light was getting to my MacBook. I was a little nervous at this point because I wasn't getting any a blinking green light which indicates data traffic, so I was a little nervous, but I still had faith, simply because the switching between Wi-Fi and your USB Ethernet interface is a little bit tricky sometimes, and it takes a little bit of time for the laptop to switch over for the operating system or whatever software that handles that switch over from getting its internet from the Wi-Fi interface, switching over to getting the internet from the USB-C Ethernet adapter. So after a little bit of time, sure enough, the light started coming through, and I had a taste of success, and the connection was successful. So that'll do it for this lab. In summary, what we did was we expanded on our local area network topology by adding a different device, which is the Raspberry Pi, and this gave us the opportunity to troubleshoot and test the IP address assignment protocols. What we determined is that a local area network without a DHCP server is unpredictable, is unreliable, because the nature of the APIPA, because of the unpredictability of the APIPA addressing protocol. So once the DHCP server was installed on the local area network, everything started working as expected, and internet connectivity started to flow between the MacBook and the router gateway, as well as communication, as well as the publishing of a DHCP assigned IP address to the ARP table, which I was able to use to ping the Raspberry Pi device from my MacBook. And so that's it for this lab. Thank you for watching, and I'll see you on the next one.